So now that we know what an antiderivative is, let's find our antiderivatives. So if we have k, that means that before we took the derivative, our function was kx. So this would be 2x, 5x, and 8x. But if you remember, on every single one, we have to put plus c because we don't know what the constant is. And then you can quickly check it by just taking the derivative. So if we take the derivative of 2x plus c, you'll see that you get 2, and then it's a constant, so 0. And it matches. So that's 2, and that's 2. So all you have to do if you see a constant is put an x next to it. And again, at the end, we just check the derivative. So that's what you do with a constant. Now we have to have our power rule just like before. So we're working in reverse. So with the power rule before, you would multiply the number in front and then subtract 1. So working that in reverse, we now are going to add. So we end up with x to the n plus 1. And if you remember before, we would take that number and multiply it. So now we're going to divide it. So like this. And then, of course, we have to add c. So let's try a few. And I like to put plus c in green. That way, if I go back and look at my problems, I can see if I forgot the c. So if we have our original function is x squared, our derivative, this means we would then take and add 1. So that would be 3. And then whatever number we get for that, we place it here as a fraction. So like that. And then what did I forget? Plus c. And so if we take the derivative, it should give us x squared. So 3 comes down, it cancels with the 3, and then 3 minus 1 is 2. This is perfect. So now we can start doing it quickly. Let's put plus 1 up here, and so that would be 9, and then you put 1/9 in front, plus c. And then plus 1, so now if we have a negative exponent, that would be x to the negative 2, and then again 1 over negative 2, plus c. And then we should write that as a negative number, so negative 1/2 x to the negative 2 plus c. And then again, remember these go on the bottom. So this really becomes 1 over 2 x squared. And that would be our answer. And it's very quick to check. All you have to do is take the derivative. So that would cancel, subtract 1, you get x to the 8th. That would cancel, subtract 1, you get negative 3. Works out perfect. So those are our two basic rules. You have constant and power rule. So now let's put it together. What if you have a coefficient in front? So here's how this works. You're going to add 1. So this would be now x to the 2. There's a 1 there, 2. And then you put the number here, 2. And then whatever number you have in front, that is just the numerator, like that. And you reduce. So this is x squared, and you can tell I've already forgotten one thing, exactly, the plus c. And now we just take the derivative. So that would be 2x, subtract 1, works out perfect. So if we add 1 to this, this would be x cubed, and that becomes my denominator. So you're going to set each one up just like that. So this one would be x to the 9, and then 9. Plus 1, this would be x to the negative 2, and then negative 2. And then now you can go back and just place the coefficient in front. And this becomes exactly what it is. Oops, forgot the plus c. See, nice green, lets me know I made a mistake. It's my pet peeve for myself, is to always make sure I have that plus c. I do forget it often. All right, I'm going to put the plus c down here because this one can be simplified. And so that would be negative 1, so negative. And then that goes to the bottom, so 1 over x squared. You still have to get rid of those negative exponents. And then you go back and you check. So that would be 2x, perfect. Remember the constant's just going to be 0. 3 would cancel, giving us 5x squared. The 9 would cancel, give us negative 4x to the 8. That's perfect. And then this one would be a negative 2. So we would get negative with a negative is positive 2. And then that would become x to the negative 3. It checks perfectly. All right, what about trig functions? So we're going to be doing a little worksheet with them to go over all the different stuff and review derivatives in the next video. But let's just look at some. So if you think about this, this is just the antiderivative. So what was the function that when you took its derivative, it gave you sine? Exactly, cosine x. But if you remember, when you take the derivative of cosine x plus c, you would end up with negative sine x. So what sign do you need to give it? You need to give it a negative. So when you have a trig function that ends with a co, you want to give it a negative. And so you can do these problems without knowing any rules. You're just thinking of what was it before? What was it in reverse? So what was a trig function whose derivative was secant tangent? Exactly, that was secant x. And then you have to put plus c. And there you go. So this is our introduction. Those are our two basic rules. You have one for constants and one for power. And the next video will show you all the rules together.